Right, I think we're ready to power this up. Now there's a couple of things I need to mention, and probably I don't iterate this enough. This is a live chassis set. It hasn't got a transformer, therefore if the connection's around the wrong way on the mains plug, and it can be either way because you see there's no key, the chassis can be connected directly to the live, and if you touch the live chassis and you're grounded, or you touch anything else that's at a lower potential, you'll get electric shock. Usually, not always, in a modern house the circuit breaker will trip if you do that. This workshop is equipped with a circuit breaker. It's a bit of a pain because when it goes off it's also connected to the lights and takes the lights out as well. But I'm running through an isolation transformer, and the isolation transformer breaks that connection between the live and the neutral, this radio and the mains. So if I touch this that's at 240 volts respected to its neutral connection, if I touch the earth lead of the socket, I shouldn't get an electric shock because I've got that isolation barrier between the primary and secondary of the transformer. I wouldn't recommend anyone working on one of these sets without an isolation transformer and be absolutely sure you know what you're doing. It might look like a teeny weeny little portable transistor radio. It will still give you a nasty main shock. Some people are more susceptible than others. They're very unpleasant when I touch them. Some people, they don't think much of it. Other people's, it can really quite seriously knock them back. It can kill you, let's be honest with you. So don't work on one of these radios unless you've got an isolation transformer and you know what you're doing. You can't ground it, you can't earth this chassis because that is one of the connections. That's one of the connections. You ground that, you'll blow the fuse. Okay, so what I'm going to do is I'm going to connect it up to the dim bulb. The dim bulb's a 46 watter. I could actually, I think what I will do is I'll start it on a lower bulb, just to be absolutely sure. So I'm going to go for our brothel orangey red light, 15 watts, so that limits our current even further. So basically plug the main socket in underneath, and this socket's also got a switch that bypasses the battery, so you can actually, when you plug in the mains, it doesn't go straight to the battery and short blow everything up sort of thing. Okay, so that's plugged into the mains. Let's plug this side into the mains. Now where's the power switch? I think it might be as soon as you switch it on. I think, is that power? Can't see a power switch. I think that's wave change. That's tuning. That must be, yeah. So let's plug it in and see what happens. Oh, just started it up without the bulb in series. Okay, so it's connected. We've got a dim glow on the dim bulb, as you can see. I think you can see it's just about in the background here. Now I've got the speaker connected up, hopefully. Let's turn the volume up and see if we can hear anything. It is all dead, but it is drawing current. Not a lot, but it is drawing current. So we've got nothing at the moment. Now we assume our speaker's okay. The next thing I'll do is to go around and give the valves a poke, see if we've got any loose connection valves. Just being careful, because there's a selenium rectifier here. It's only a half-wave rectifier, but if you touch the DC side, it'll bloody hurt. Okay, at the moment no sound. So I think the next thing to do is to check that we have actually got some DC voltage on it. We should have a 90 volt or so supply to the 118 there. Okay, so it looks like we've got a high voltage supply. As I was saying, I'm a bit worried that possibly some of these valves have been overcooked. I can't see. The trouble with these very low powered valves, you can't see the filaments in them. So what I'll probably have to do next is to take them out and just check the filaments. I just can't see any signs of anything lit in there. Now a lot of these valves I have actually got replacements for, but I'll have to search those out. I'm just hoping that's not the case. It hasn't been wanged up and someone's blown the valves. So let's go to full power briefly. Let's just tip it over, but there's no signs of any life at all. I suppose the other thing to do is to make sure the speaker's okay. So let's just turn that off a minute. Just so we've got continuity of the speaker. Says that's a dead short circuit. Just checking the continuity of the. You can see. Okay, 3.6 ohms, that's good. And of course the dead short circuit is because we're across the secondary of the transformer, so speaker's okay, that's good. You connect that back up. Right, the next thing to do is get one of these valves out, and so we can work out where the filament connections are. Now usually, when my eyes were better, I used to be able to see where the filament connections were. Of course I could always download the data. It looks like those two possibly. Not showing any continuity there. Oh, actually no, I think I could see them. No, it's looking promising. So maybe it has got connections. Let's re-plug it back in again and have a bit more of a fiddle around. I don't think there's anything seriously wrong with this radio. Could be wrong. That's the famous last words, but I just get the feeling there's probably not much wrong with it. It's just been put away, and it's. Let's power it back up again. Because there's no sound at all, it makes me suspicious of the. Oh, we've got sound. We've got sound. It's very weak. Okay, we've got sound. It's very, very weak. Better? So that's full volume. But it's clearly working. That sounds like long wave. No, it's pretty medium wave actually. Very, very deaf. Let's try on another band. I mean, it is working, but it is extremely deaf. Let's go back to long wave again. Just check the valves are all in properly.
Along with Spain.
There you go. That's the detector valve.
Amongst the top two.
Well, that was easy.
Europe.
I've got the sensitivity back.
Of course, I don't think there's any doubt about it.
Try the other band. Okay, so yeah, it looks like it works. So what I'm going to do now, I think we'll turn it off and get the valve sockets. The valves are good clean. So we'll just all we'll do is we're going to turn it over. I'm going to take out each valve one at a time. This is little tiny valves, the DF96 Mallards. I think this is this one's an IF amplifier. I'm pretty sure. You can see the pins are pretty clean, but I'm just going to give it a squirt of contact cleaner in the valve seat. Pop that back in. get that. One of my Mallard book shows what this is. This is a DK96. Let's just see if my little Mallard book shows me that. I don't think it does. See, does it do the D's? D. I just want to. No, that book doesn't. Just if I've got a book that gives you any information on the valve data. RCA receiving the tube data. And if that's got any cross references. No, I don't think it has. 12 numbers earlier, sort of like there's equivalence. Somewhere I've got a book that tells me all the valve data. I can't see it at the moment. Okay, so anyway, let's just give that a clean out. Put that back in. Fiddly little valve to get in. Bear with me whilst I get this valve in. I'm not advertising WD-40, by the way. Might just look like it. Oh, this is really tight because we've got this IF transformer in the way, tuning capacitor one side and the aerial the other side. Okay, it helps when you can see what you're doing. It should go in that way. Okay, there we got it. So that's that one in. So it's these other two valves. One will be the output valve, and the other one will probably be the detector. So we've got the mixer or frequency changes, what the Brits call it. 2 IF amplifiers, and then the detector in the output stage. I think this is the detector. That's it, and the output stage is this one, DL96. Ooh. What I'll do is, once I've got this all working reasonably well, I will do what you should always do first. And I know one of the Canadian YouTubers always really winds me up by spending hours and hours trying to repair a radio, and then finds that one of the switches in the tuning gang isn't working properly, and he's got to go through it all again, and he's done it so many times. He's a very entertaining chap to watch, very nice chap. He's got a couple of cats. I'm sure you probably know who he is. But it doesn't matter how many times I leave a comment, he either deletes them or ignores them. I suppose it's up to him. Okay, so now we're going to go with proper contact clean and just give the wave change selector switch a squirt. Without trying to spray any of the trimmer cap. Give that a wiggle. Okay, and then the volume control. And don't use WD-40 for carbon. I always use, this is Servicol Super 10. The Americans use deoxit most of the time. Deoxit's very expensive and it's hard to get over here. So I've always used Servicol. I used to use the RS stuff actually. When I used to work at the hi-fi shop, I used to use the RS contact cleaner. It was one in a sort of like a blue can, which was the non-lubricated one, and the other one was in a red can, and they used to work pretty well. But I get this on eBay, so it's easy enough to pick up. Okay, let's plug it back in and see what we get. That's helped. It doesn't work at all now. Yeah, it's still got a dodgy valve here. Yeah, the valve's still messing about, probably.
Maybe international football, and really with the state of his performances, you have.
Okay, so we've definitely got problems with the valve socket or the actual valve itself. Now, I think what I'm going to have to do, particularly that valve there, just turn it around so you can see, it's disconnect the speaker. This valve in here, this one right at the back, is particularly difficult. As you can hardly see it. Here we go. It's that one there, right in the back. Get that out again. Now it could be just because the contacts have gone a bit sort of verdigris on them, but you see they look reasonably well. What I'm going to do is just get a small wire brush and just run across the valve legs, just to remove any oxidization on them. Give them a bit of a scrub. Careful not to bend any of the pins. Just pop that back in again. Funny is, the older you get, the harder it is to sort of manipulate little things like this. Get this one out. This one's another one that was a problem. Doesn't look too bad, does it? Let's give it a clean as well. Same process. You can use emery paper. I don't tend to like using emery. It's the last resort. It's a bit too aggressive, I think. Pop that one back in. I might as well do this one because it's easy to get to. Same thing. I suppose I might as well do the last one. This one doesn't look so bad. The pins look quite sort of shiny on this. I think this is the one that's right at the back of the radio, maybe, because these things run pretty cool anyway. Maybe it's just run a little bit cooler and hence hasn't got some verdigris on it. Okay, let's reconnect that speaker up. Better?
That we moved away from. Yes, it's dimming, and we're expecting some rain probably within the next 20-25 minutes or so. So we'll have to wait and see whether this match does get controlled.
The valve socket's still a bit crappy.
The Egyptian FA have confirmed that
It's clearly working pretty well. I mean, it's not super.
For an Ocean credit card before you
There we
apply.
go.
Checking doesn't affect your credit.
Goes pretty loud as well. The next thing to do, is to find out some data on it, and what we'll do, I think, before we do that, actually, before we go through any of that, we'll just check a couple of components underneath just to see what condition they're in. So that'll be the next stage, checking a couple of the resistors and capacitors and just see what we're getting. I hope you can see the meter okay. So we're just going to go through a couple of these resistors. These are carbon resistors. They're usually pretty rubbish. So we'll start here, this brown, black, red, which is a 1K. And straight away that's showing 14 ohms, so that's not right. Possibly because it's across the valve heater. Okay, I'm not going to worry about that one. It's straight across the heater. Let's check this one then. Red, violet, orange. So that's a 27K. That's measuring 31.2. That's 20%. So yeah, that's all right. What about this one? This is 100K. Oh, 100K. It's good. There's one down here. Where is it? This one here, orange, 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 is 33K. Measuring 43. Yeah, a bit high. Let's try this one over here. Orange, orange, brown, 330 ohm. That's measuring. And get a connection on it. 17 ohms, up across the heater again. Okay, I think what happens is if one of these valves filament goes open, it just passes a bit of current through. I'm not entirely sure what that is, or it might be some sort of decoupling. Let's have a look up here. What have we got up here? Okay, we've got where is our connection going to? It looks like down there. These are all a bit fiddly to get to, these ones up here in the top corner. I'm trying to keep the meter and the radio in the same view. Let's see if we can get to this one. So this is a red, yellow, no, red, yellow, brown. Is that red, yellow, violet? It can't be violet. Red, violet. This must be 24, 240 ohms. It's measuring 16. Red, yellow, brown. Well, it's certainly not high, is it? So I'm not worried about that. I don't think I'm worried about that one. Got another one down here. Let's see where that goes. That's a 330 ohm. That's measuring 18. Oh, that's one of the filament ones as well. Let's try some of these other resistors here. What's that? Red, red, green. It's showing about 2 meg, so that's about right. There's another red, red, green here, so it should be about the same, about 2 meg. It's an IF coupling by the looks of it. 2.7 meg. Yeah, that would be okay, because it's such a high value. I wouldn't have thought that'd be a problem. We could always change these out at a later stage. Okay, so it looks like the resistors are not wildly out. Some of them are a bit high. So the next thing to do is we'll check the couple of these capacitors here. I'll do that with the 4261. So let's check this one first. This orange capacitor down here. Should we get the right connection? I'm doing it in circuit, which isn't always ideal. And that's measuring, if you believe that, 141 microfarads with a 0.2 dissipation, which is, if that is right, is pretty good. And it's 100 microfarad. Yeah, it could be possibly a little bit leaky. It's hard to tell in circuit. What we could do is drop that out of circuit and just check that. But it initially looks okay. It's got no snot coming out the side of it, so that's good. Let's just check this little cap here. Might have to go up in frequency a bit. And that's measuring 148 nan. But dissipation factor's off the scale, so it could be that this capacitor's faulty. It should be half a microfarad. So we might have to actually disconnect that one just to get that one checked properly, because it could be just the way it's wired in, but it does look a bit suspicious, that one. We don't want any leaky capacitors in here really. You've got a couple of wax capacitors here, but these are all low voltage in the RF section. They won't have any potential across them. There's a couple of these Hunt's brown jobby things. And that's, yeah, likewise it's measuring over range, so it doesn't look like it can actually measure that, because it's probably so small. So there's nothing obviously short in here, and clearly the radio works pretty well. What's this say under here? There we go. Look up the model number. Ferguson Radio Company Limited, Made in Great Britain, model 342BU. Okay, so let's have a look, see if we can find some information on that. Then we'll do I think we'll just do an RF alignment. It seems to be in pretty healthy condition. So the next stage will be do an RF alignment and then see how it performs, and maybe start looking at the case. Well, I found the service manual, the genuine original Ferguson manual. It's the model, there you go, 342BU. Description is a 4-valve portable receiver with built-in ferrite rod covering medium wave and long wave bands. It is designed to operation on AC and DC mains or with self-contained drive batteries. Blah blah blah. Controls, three controls arranged concentrically in the front panel. Then we've got general specifications, obviously the frequencies it does. Now valves, here we go, all mallet typed. DK96 frequency changer. So the frequency changer is the valve that takes the RF incoming signal and the local oscillator and mixes the two together to do the frequency change for the IF. V2 is DF96, an IF amplifier. V3, which is a DAF96, is a detector and audio amplifier. And then DL96 is the audio output stage. And it says power supply and 90 volt battery and 7.5 volts for the low tension. What else does it say? Anything else that we need to know? Be interesting to know the it's got the calibration here, but I just wanted to see if it says anything about IF frequencies. Probably a 460 normally on something like this, but not always. Nice manual actually, nice and clear, nicely clearly drawn out. Now I'll get these up on the computer screen when I think probably inject a 470 kilohertz, so it's a 470 kilohertz IF. So what I might just quickly do, just to check our alignment, is just run up the Roden Schwartz and just sweep past 470 and see if it seems to peak around 470. That will give us a good idea if the IF is roughly aligned, which I think it is actually. It seems to be performing pretty well for a set like this. So let's do that quickly. So just to run through how I do this, the Roden Schwartz signal generator you've seen before. It's connected to this lead here, and underneath the bench there's back of an old valve radio with a loop antenna, and basically I just radiate through the bottom of the bench. It just means you don't have to connect up aerials and things. It's good for a rough test, just to make sure everything's roughly working correctly. So let's plug the radio back in. And it takes a couple of seconds to warm up because the filaments have got so low mass and they're directly heated. So tuned to a medium wave. I think that valve's still messing about. Yeah, so we need to sort this valve out. It's probably the valve socket. Okay, so let's just sweep 470 so we can find it. Oh, turn it on the right output. Okay, so we're looking for maximum volume. Just looking pretty good actually. So it looks like it's about, let's see. So that sounds promising. So it sounds like the actual set's probably pretty well aligned, certainly in the IF amplifier. So let's do a quick run through on the IF amplifier, get that in line, and then we'll do the RF section. So I think what I'll do is I need to sort that valve out. I can't criticise someone else for not having bad connections in their radio, and then go and do an alignment on a radio with bad valve sockets. So let's get this sorted out. So I think let's unplug it. give it a. You should also wait for sort of like really a couple of minutes for the capacitors to discharge in the high tension circuit, but it's only 90 volts, and actually 90 volts DC doesn't actually. I can't actually feel that, believe it or not. Some people can, some people can't. So I'm going to just have a quick look at this valve socket down here. I'll try and get you in view as well. I don't know how well you'll be able to see this. So it's the valve socket just to the left of the tuning capacitor, just there, centre frame. It's that bugger there is causing the problem. You can't see anything obviously wrong. I can see all the contacts. It doesn't look like any of them are broken off. You know how close you can get before it all goes blurry. But they look pretty good. So I'm going to spray in some service oil in there again. Give it another wriggle around. This is a... went in first time that time. Okay, so let's power it back up just to see if we've got a better connection. No, it doesn't sound like it. Oh, maybe it is. There's a really bad connection somewhere. Let's just turn the radio when it's on and just have a poke around underneath, see if we can find anything obviously wrong on the bottom of the valve. So, this is the valve. Is it that valve? Yeah, so it's this valve here. One of these is buggering around. Okay, this doesn't seem to be doing it now, so here's one of these resistors messing about. Something wrong there, isn't there? Okay, so we've definitely got a bad connection here. I'm trying to work out what it is.
You can see like where they're going, even if it doesn't go perfectly for Spain.
Oh, it seems right now.
It's a disaster.
Okay, so
I think you can see a clear line of where they're going. With Belgium, I'm not too sure. There was always the question.
It's the only radio channel you can listen to where you won't get copyright.
There are a lot of big names in that dressing room, as you quite rightly point out.
God, I hate football.
Team anymore, which players of an age.
Now that's not the connection problem. That is because I'm adding capacitance to it.
That's very much to
Try this.
appease the best players in the team. It's funny when you talk to players around the squad and people who know players around the squad. They will say,
I think it's just a bad connection on the top. I don't think there's anything wrong with the components on the bottom. So I'll just give the valve a clean up before we when we finish. So let's just do a quick check of the IF alignment. See how I adjust these cores. So 470 kilohertz I'm just going to do this by ear, perfectly acceptable on a radio like this. Okay, tuning gang fully tuned, fully meshed, 470 kilohertz on the dial. These, you can do these with little pointed nose pliers because they're metal, so you're not going to break cores or anything like that. Let's turn this round to get to it. So let's try this first one. So that's just a paint on the top. I'm going for maximum volume on the radio. Turn the drive down a bit. That's well peaked, that one. I don't think we're going to improve on this at all, which I sort of didn't expect to anyway. No, I don't think we're going to improve on this. Turn the radio over. Cool. Because the arrow's being fed straight in from the underneath, so it's right against the ferrite rod, so it's just putting a strong coupling into the radio. So we want the RF as low as possible, really, and the volume as high as possible. Try the bottom one, so it's still at 470 kilohertz. Maybe a slight improvement on that one. And this last one up here. Bit fiddly. Very slight improvement, but not a lot. So that's pretty good as well. Yeah, the IF alignment's basically correct. So the next stage will be to let's do the RF section.